So when thinking about the absorption of chromium, there are a few different routes that can be used depending on the source of chromium that we're starting with. So the generally accepted theory for inorganic chromium is that it's going to be absorbed using a paracellular route. And again, the bioavailability of this inorganic chromium is very poor. Now, once in the bloodstream, that chromium is going to bind to our chaperone protein transferrin that we talked about a few slides ago. So again, transferrin is able to bind chromium as well as iron, and the binding constant with chromium is about 10 at one of the binding sites and about 5, so much weaker, at its other binding site. Now, chromium propionate is probably going to be absorbed using some kind of cell-based mechanism, so some kind of transporter is going to be used. But again, once it's in that bloodstream, it's going to be losing that chromium to that transferrin chaperone, because even though the propionate is able to bind that chromium probably strong enough to get through the acidic environment of the stomach, it's only binding with a stability constant of about 7 and change, right? And so because that transferrin molecule has a stronger binding constant with that chromium, the transferrin is going to be able to steal that chromium away from the propionate ligands, and ultimately that chromium propionate is going to be circulating through the body the same way that an inorganic source would be moving through the body. Now, our Zinpro chromium methionine product is going to be different, right? So most likely we're going to be absorbed using some kind of peptide transporter, not the amino acid transporters, because with 3 amino acids bound to that chromium, it's a much larger molecule, right? So it makes more sense that we'd be using a transporter that's looking for a larger substrate. But since our binding constant is 14.5, we know that we're not going to be losing that chromium to the transferrin chaperone once it hits the bloodstream because we're binding more tightly. So this means that our chromium methionine product is going to be moving through the bloodstream differently compared to other organic sources and compared to inorganic chromium. And so now we get to Andi's grand theory of why our Zinpro chromium is going to have our performance benefits. So again, I want to stress that this is like just a theory. We haven't actually tested this yet in any kind of cell model. We're looking into how we could test this, but it's my current best explanation for why we see that difference in animal performance in response to Zinpro chromium versus other forms of supplemental chromium. So we talked before about how the insulin receptor is going to work to bring those glucose transporters to the cell surface and clear sugar from the blood, right? And that's going to happen in response to that insulin molecule binding to the receptor on our target cell surface. And then eventually, once that transferrin receptor is brought to the surface of the cell, we can have chromium into the cells and potentiate that insulin signaling. So I think that our Zinpro chromium is going to act differently here because we're already going to be inside those target tissues by the time that insulin signal gets sent. So because our chromium methionine is going to be absorbed using a peptide transporter, again, most likely we're still looking into this as well, we know that we're going to be absorbed into those target cells when they need more amino acids or peptides to use for protein synthesis. And so those transporters are going to be expressed far more often, far more regularly, because the body needs amino acids more than it needs trace minerals most commonly, right? So if we already have that chromium methionine inside the cells, we know that we are very tightly bound to that chromium, again with that stability constant of about 14.5 or so, if I'm remembering off the top of my head. But that chromogenum chaperone inside the cell is going to be binding with a stability constant of about 21. So it's binding even more tightly to that chromium than our methionine molecules. So it's able to break apart our complex and get the chromium where it needs to go in order to be used by the cell. And so again, it's going to start potentiating that insulin signaling more quickly compared to the inorganic sources. And so that's going to allow us to get even more of those glucose transporters to the cell surface to start clearing more and more sugar out of the blood after meals more efficiently. And so that is how our Zinpro is going to act differently than inorganic sources. Again, just a theory. I do not know this for sure. Please do not take this as a fact. But because we're already inside those target tissues, we're able to potentiate that insulin signaling from the get-go and get more and more sugar out of the blood and into our target tissues.